Okay, in Unit 8-9, we're going to revisit quadratics. We're going back to quadratics, and we're going to do some applications, some word problems. But before we do that, we're going to review completing the square. So if you remember, completing the square is where we change standard form, which is ax squared plus bx plus c, and we change it to vertex form, which is a times x minus h squared plus k. So the reason we change it to vertex form is we want to find the vertex. And when we're doing word problems, that vertex is going to represent the maximum or the minimum, depending on the question. So in vertex form, we have an x minus h squared. So that means we have two x minus h's. That is a perfect square. So when we have it in standard form, we want to create that perfect square. So if I have y equals x squared plus 10x, and I want to factor to get two factors that are the same, I know that they would have to be 5 and 5. Because if I take 10 and divide it in half, I know that each bracket to be the same would be 5 and 5. To get that last number, 5 times 5 gives me 25. So 25 creates that perfect square. So we don't really need the -3. We want it to be 25. But whatever you add, you have to subtract, because we don't want to change the value of the equation. And then we still have this -3. So I'm adding 25 to make a perfect square quadratic. So this quadratic factors to x plus 5 times x plus 5. Whatever I add, I have to subtract, so I don't change the equation, and then I have this -3. So I can add the 25 and the 3, and then I can write this as a square. I have x plus 5 twice, minus 28. So that equation is the same equation. I've just changed it into vertex form rather than standard form. So now I know that the vertex would be -5, -28. Okay, let's try another one. So x squared minus 8x plus 1. So again, I'm only going to look at the first two terms. If it's x squared minus 8x, and I factor that to two brackets that are the same, they would both have to be 4, because half of 8 is 4. So I do 8 divided by 2, so they'd both have to be 4. -4 times -4 is plus 16. So that's what I need to make a perfect square. Whatever I add, I subtract, and then I have this plus 1. So -16 plus 1 is -15, and then I'm going to write x minus 4 as a square because I have two of them. So the vertex would be +4 and -15. If you have a coefficient, you have to take that into consideration. So you actually have a stretch. We did transformations in Unit 7, and we know that that 2 is a stretch. So you have to separate the stretch of 2 from the first two terms. Again, we're going to ignore the 7. The 7 is not helping us, so we're just going to ignore it till the end. And we're going to factor out the 2, not only from the 2x squared, but also from the 12x. Which leaves us with 2 times x squared minus 6 x. Then we're going to factor that. So since it's 6, we know it's going to be 3 and 3. 3 times 3 is 9, so we'll need a 9 to make the square. We'll do a -9 so we don't change the equation. And then I'm just going to put square brackets around that. And I still got this plus 7, because if I factor that to 2, I then have to multiply by the -9 when I simplify. So we've got 2, we've got x minus 3 twice, we've got 2 times -9 is -18, and then plus 7. And so my vertex is 3, -11. Okay, one last one. So again, we've got a coefficient. So we want to factor out that stretch of -3 only from the first two terms. We're going to ignore the negative 1. So we'll take out, so 18 divided by negative 3 is negative 6. Then I'm going to complete the square. So since it is 6, it would have to be 3 and 3. Negative 3 times negative 3 is positive 9. That completes the square. Minus 9, so we don't change the equation. And then we have a minus 1. So we have to remember that this negative 3 has to be multiplied by that negative 9. So positive 27. And then we'll write it in vertex form. X minus 3 all squared plus 26. So the vertex is 3, 26.